Hello, everyone. My name is James Arnold, and I'm a solutions engineer for Keysight Technologies. Today, I want to show you how to set up your PathWave test automation bench for our SL1221A anti-islanding compliance test software. This is the first step you need to perform before running any test using the software. All right, so the first thing I'm going to do is I'm going to go down where it says Instruments to the right and click on Add New. Then in this new window that pops up, we'll click the plus in the bottom left corner. And then we will select a AC emulator to add to our bench. And we'll use that Keysight SL1200A AC emulator. Firstly, we're going to put in the IP address of the director unit, or if you're using just one unit, just the IP of that one. Then we'll select the model number of this unit, or we can click the Retrieve Device Number button there to just grab it from the instrument itself. We'll click that plus again and then select our DC source. So today I'm using one of our Keysight RP7900 bidirectional regenerative power systems. So I'll go ahead and add that one to the bench. And then for this one, we need to add in specifically the Visa address. So this is using our Visa COM driver. You can get this pretty easily through our Keysight Connection Expert software here. And I already have my instrument connected, so I can go down to the Visa address there, copy that, and then paste it into the window here. Then click the Retrieve Model Numbers and Max Min Settings button to populate all of our settings. All right, so now we're going to go over to the DUTs tab, and once more click the little plus icon in the bottom left. We will add now a power inverter. And so at the top of our settings, we can choose where our data is logged or leave it at the default. Then we can put in some basic information about the system or our EUT. So I'll put in a quick description here. Then we need to put in our power ratings, so active power in watts, apparent power in voltamps, and reactive power absorption and injection ratings in VARs, and finally the efficiency. For communications, we support either manual or Sunspec Modbus. So in manual control, you'll use another software to control the settings of the EUT. Then we can choose whether it is applied primarily by the DC or the AC, so which is applied first from a cold start. And then delay before connect is just how long between power apply and first communications. Really only applies if you're using Sunspec Modbus. All right, then we can set our AC grid topology. So by default, this will be a three-phase system, 277 VRMS line to neutral, 120 degrees apart, with neutral being ground bonded. So basically nominal conditions for the US grid. And then next we'll set our AC voltage limits. So our peak voltage maximum, our peak voltage minimum, so the positive peak and negative peak of the voltage waveform, as well as the protection delay. We'll do our RMS values as well. And so what the protection delays are basically is how long do these conditions need to be present in order for a trip to occur. And when a trip does occur, this will open the output contactors of the AC Grid Emulator and halt the test entirely. So these are protection trips. We also have them for current, as you can see there. All right, and then finally, we will set up our DC settings. So the nominal rated VDC, this is actually what the DC source will be set to if it is being controlled automatically by the software. So here I will set it to 750. The max input VDC will be kind of a safety or upper threshold, something that we'll never program. The timeout for current flow is how long we'll wait before the EUT needs to get up to steady state power. So if it takes more than 10 minutes by default, then we'll just stop the test. Power down reset time is how long we need to be shut off in between iterations. And the power on rise time is how long to take to apply DC voltage to the EUT. And finally, that maintain DC power to EUT checkbox just keeps the DC power applied to the EUT for the entire test. So the DC side would never shut down if you had that selected. All right, that's about it for the basic bench setup for the SL1221A P-Hill-based anti-islanding compliance test software. Thank you everyone for watching and have a great day.